Hello. Oh, there's that scratchy voice again. Let me get a quick drink here. Okay. I'm going to try and get through this. I wanted to give you a little starter video on how to attack part two of our quadratic modeling project. Um, as you can see, you're presented with a table of values, and you're asked to create a quadratic model using this data. So the good news is that there are tools, including Desmos, which can quickly create the model for us. And that's the goal of this part, for you to just run through that process of using the tool to help you create the model. The tool has been programmed using some complicated mathematics. That math is sort of beyond the scope of our class, but we certainly want to be able to take advantage of that tool to help us create a quick model. So we're going to run through that process. In this case, our table of values is showing us the distance that a baseball will travel depending on the angle at which you hit it with the bat. I want to point out that the numbers in my data table in the video are just an example. They are not the ones that are in your actual document, so you'll have to make the adjustments to that. But essentially, you have 5 items that you're going to work through to get the points for this part of the project. I want to remind you that as you're answering each of these items, this stuff goes in your notebook. You're going to handwrite these answers. You can use Desmos to help you get the answers. And then at the end, you'll sketch a graph with all of the components. And you'll write that right in your notebook and then submit those pictures. Okay, so let me just dive right in and show you how we use Desmos to create a model quickly. We use something called quadratic regression. All right, I'm going to switch over to Desmos, and when you go there, start a new graph, and you'll be presented with the typical screen. In this case, since we don't have an equation yet, what we're going to start with is the table of values. So to do that, I go ahead and get the plus sign, and I add a table. And it will provide us with an X column and a Y column. And then we want to enter that data from the assignment in. So I'm going to start by entering my angles, 10, 15, 30, and so on. Sorry, you got to watch me do this, but I think it helps for you to, oops, apparently I'm not paying attention. Let's try this again. I have to look up at the screen and down at my notes. Sorry. The voice isn't the worst part about this video, apparently. Okay, here we go. I'm on the right track again. 42, 45, 48, 54, and 60. All right, so those are the angles. Those are the X values for my data. And then the distances will go in the Y column here. So 42.3, what is it, 64.1, 111.0, and so on. I'm going to stop talking and save my voice a little. Plus, you don't need to hear me read all of these numbers off. Okay, so all I did is I read off the numbers from my table in the assignment. Here they are again, and I think I typed them all in correctly. And I entered those into the table feature of Desmos. All right, now we learned in part 1 that if you want to see your data, you need to zoom to fit the data. So I'm going to go over here and I'm going to hit that zoom feature so I can see my dots. Okay, so now we've got our green dots on the screen, and you can kind of see they sort of make the shape of a parabola. It's not perfect, but that's the data we're given. And what we want to do is create a model, right? An equation that will represent as best we can the data that we're given here. So here's how the regression works. You click a new cell underneath your table. And since our model is just an approximation of the data, we're not going to use an equal sign when we create this graph. What we're going to use is what's called a tilde. So it's like a little squiggly line. I'll show you here when you get it. But the way we set this up is we want to define our y values, which is our y1. So you got to type y1 there. And then instead of hitting equals, use the tilde symbol. Mine is up on my keyboard next to the number 1, and I have to use shift to make it show up. But it depends on what keyboard you're using. If you're on your phone, Let's see. I have no idea where that sucker is. There it is. You go right here to the ABC part. You hit ABC, and then there's the tilde right there. So you can use the keyboard that's provided by Desmos. Once you've set up y1 tilde, which means approximately equal to, then we want to write out the format for a quadratic equation using the variable x1. So the standard form is ax, so I'm going to write ax1 squared plus bx1 plus c. And when you do that, Desmos uses regression, which again has been programmed to do, to create a quadratic model. Right now it's in black. I'm going to make it blue and just make it a little bigger so you can see it here. I guess it won't let me make it bigger, so I'm not going to worry about that right now. But there it is. It's in blue. And while we're at it, let's make my dots red just so they show up a little better in the video. There's a contrast there. So the red dots are the actual data points, and the blue curve is my model. All right, so now we have a quadratic model. Our model is, y equals negative 0.0691838 x squared plus 6.08958 x minus 11.2787. And that's the model that you're going to write in for the answer to your letter A. When it says find the quadratic equation, you're going to write that out, y equals, and use all of those numbers. Go ahead and use them, including all of the decimals that you're given. All right, so if it's got 5 or 6 decimals, just copy them down. All right, and it's going to have the form that's listed here. So the A number goes there, then x squared plus the B number, then x plus the C number. Okay, that's how you answer letter A. Letter B says find the angle that produces the maximum height. Well, we practiced that in part A. You have to select your model, and then you'll notice a little gray dot shows right up there at the vertex. So you tap that dot, and sure enough, the angle is 44.01 degrees for me, and the height is 122.723 meters. And when I answer that letter B, I'm going to write down the angle, which was whatever it was, 44.01. For letter C, what was the maximum height? For that answer, I'm going to write down 122.723 meters. Okay, let's go back to our assignment here. Letter D, it says use your model to predict the distance the ball will travel at an angle of 72 degrees. All right, so we can do that right from the graph. There's a couple of different ways to do it. The fastest way, I think, is just to make a vertical line at x equals 72. So I'm going to type in x equals 72, and then I just check to see where it hits. So the distance there is 68.523 meters. Go ahead and use all 3 decimals. All right, so then my answer for that particular problem, letter D, is 68.523. And then finally, you're going to make a sketch of the graph that you have here in decimals. So some features that you're going to want to label. Make sure you label that top point, which we already said was here. For me, it was 44.01. So label that point. We want to label these zeros. So that's where it crosses the x-axis. And then you also want to label this point here, the distance that you travel at 72 degrees. It also said to label your axes. So just to remind you that our x-axis, and I can do that here, our x-axis is the angle. And then our y-axis is the distance. So when you draw your graph out, make sure you include those labels. You can see decimals popped them out here and here. If you want to make a screenshot and submit this picture, you can, but that's in addition to also drawing out the graph. All right, so still add that to your notebook by hand, include the labels, and label those points that I asked for in letter E there. Okay, so that hopefully will make this part 2 very fast. You type in the table, you create the regression model just by typing exactly what I have listed here, which is y1 tilde ax1 squared plus bx1 plus c. Desmos takes care of the rest. It draws the curve. It gives you the answers for the coefficients. And from there, then you can just set x equals 72 to get your height there for the last part. So that's just a quick sort of exercise in running through creating a quadratic model. We're going to do this again in our final project in week 7 with exponential functions, but this is our introduction for quadratics. Okay, as usual, this may generate questions, and please feel free to ask. You can throw them in the forum or send me an email or pop a message on My Open Math. But please do ask questions if you have them. I'm happy to help. But I'm hoping this will get you in the right direction. And I apologize again for the scratchy voice, but it's all I got today. So best of luck this week, and keep me posted on your progress. Take care.